Hello, ladies and gentlemen. I hope that you are enjoying your fall break. Here is your homework assignment, or your video to watch on, I'm assuming, Sunday night. So we're going to be graphing and solving quadratic inequalities. All right, so that is our task for today. Your objective is going to be, we're going to first review graphing our quadratics. Then we're going to solve the quadratics and we're going to solve those in terms of an inequality. Okay, so that's what we're going to do first. We're going to review our graphing of quadratics, and then we are going to solve some quadratic inequalities. All right, so first let's go back and review what the standard form for a quadratic actually is. And that's going to be y is equal to ax squared plus bx plus c. If you'll remember, a is your vertical stretch or shrink, and then c is going to be the y-intercept, which is really helpful if we're graphing. All right, the next form is our vertex form, which is particularly helpful for graphing. Okay, so I'm going to put helpful for graphing, and that is going to be y is equal to a times x minus h quantity squared plus k. And if you'll remember, there are a couple of different ways that I can get an equation into vertex form. One is by using h is a negative b over 2a, and then k is equal to f of h. Okay, that is my least favorite method, but if I have functions that have weird fractions, that's actually kind of helpful. And then the other method is by completing the square. That's my personal favorite, so that will be the one that I suggest that we use the most. All right, so let's start with a graph. Oh, and let me tell you one more. Sorry, I forgot this one. Intercept form. And if you'll remember, intercept form is of the equation y is equal to a. Notice that a is the same in all three forms, and then it's going to be x minus q and x minus r, where q and r are, sorry, that's kind of weird, your x-intercepts. All right, so now let's review a graph, because I think graphing is something that we all struggle with a little bit. So let's work on that. I'm going to have y is equal to a negative x squared plus 4x plus 2, and I want to graph it. All right, I'm going to do completing the square because I think it's more efficient. So I'm going to I'm going to start by taking out a negative 1, and I get x squared minus 4x, leave some space, push the 2 over. Okay, half of 4 is 2, squared is 4, so I'm going to write a plus 4 right there. Notice that this is a negative 4, so this is going to be a plus 4 because the net effect has to be 0. Then I am going to simplify, so there's my negative 1, x minus 2 squared plus 6. So I know a couple of different things about my graph. I know that my vertex is going to be at 2, 6. I know my y-intercept is going to be 0, 2. And that's enough information to come up with a nice, accurate graph. So if I draw my coordinate system, my vertex is 2, 6. So there's the 2 and 1, 2, 3, 4, 5, 6. Okay, there's going to be my vertex. I do know that the parabola points down because the A is negative. All right, my y-intercept is 2, so 0, 2. I'm going to just draw very lightly my axis of symmetry. I'm going to reflect this point across. Now I'm going to connect my dots. And now I have a fairly accurate parabola. Okay, so that's how we graph our quadratics. So now what I want to go back and review is solving an inequality. Okay, so let's review. We've done this before. So let's review solving an inequality. For instance, if I'm given 3x plus 5 is less than or equal to 1, I'm going to solve that equation. So I'm going to do 3x is less than or equal to 1 minus 5. 3x is less than or equal to a negative 4. Divide both sides by 3, and I get x is less than or equal to a negative 4/3. All right, I'm going to draw a line graph. I'm going to put on 3 points. Oops, I forgot the 4. There's a 0, and there's my positive 4/3. If you'll remember, this says it's less than or equal to, so that means I have a closed dot on the negative 4/3 because that means it's part of the solution, and then my graph goes that way. All right. If I put this in interval notation, which is what we will spend most of our time this year doing because now we're in big kid math, then I would write that as a negative infinity to a negative 4/3, and the 4/3 is included. So a couple of reminders about my interval notation. I write left to right. An open bracket means not included, and a closed bracket means included. So that's all information that we've covered in the past. All right, so now let's do a different type of inequality just as a way of reviewing. So here's going to be your example, and I'm going to have a negative 4 is less than 6x minus 10 is less than or equal to 14. That's called a compound inequality. All right, so if you'll remember, I'll solve this piece, and then I will solve this piece, put the two solutions on a number line and see either where they overlap or where they create unique intervals. So if I start that process, I'm going to say 6x minus 10 is greater than a negative 4. Notice I really didn't change anything. I just put my variable on the left. I'm going to add 10 to both sides, so negative 4 plus 10. So 6x is, forgot the x, greater than 6. Divide both sides by 6, and I get that x is greater than 1. There's the first piece of my compound inequality. Now I'm going to do the right-hand side. 6x minus 10 is less than or equal to 14. Add 10 to both sides, less than or equal to 14 plus 10. 6x is less than or equal to 24. Divide both sides by 6, and I get x is less than or equal to 4. So now I'm going to put that information on a number line. Okay. All right, so my first one said, I'm going to put my 3 points, that x was greater than 1. That means there's an open circle on 1, and my graph would go to the right. Okay. This one says x is less than or equal to 4. I put a closed circle on 4, and then my graph goes to the left. The solution is where those two areas overlap. If I put it in interval notation, the 1 is not included, so it's a curved bracket. The 4 is included, so it's a square bracket. All right, so those were the first couple of types of inequalities that we did. Then we moved to another type of inequality, and we talked about lines. So let's say I had y is greater than or equal to 3x minus 4. That's the equation of a line. So if I graph that line, I know that its y-intercept is a negative 4, so there's 1, 2, 3, 4. There's my negative 4. And I'm going to put a couple of numbers on the x-axis. My slope is up 1, 2, 3, and over 1. 2 points define a line. See if I can connect my dots well. And there's my line. Now I have to choose which side of the line to shade. So I'm going to use a test point of 0, 0. I'm going to substitute it into my equation. Is 0 greater than 3 times 0 minus 4? Is 0 greater than or equal to a negative 4? It is indeed, so I would shade the true side. And if you'll remember, the line is part of a solution, so it says greater than or equal to, therefore my line is a solid line. So that is the type, sorry, bad grammar, that's the type of problems that we've solved so far. So now we're going to take that process and apply it to our quadratics. So here's our first example, and we're going to solve a quadratic inequality, and then I'll show you a cool trick on your calculator, so it's kind of fun to play on your calculator. All right. That's assuming then that you have a grapher at home. You're going to need one as the year progresses. So I'm going to be given an equation y is greater than x squared plus 3x minus 4. Because I am graphing, I need to find some important points. I need the vertex, and I would also like to find the x-intercepts. And I will explain why we find the x-intercepts a little bit later. And hopefully the shadows aren't too bad so you can see. So the first thing that I'm going to do is I'm going to put this into vertex form. And I'm going to do it by completing the square, because again, that's my favorite method. So I'm going to do y is greater than x squared plus 3x. I'm going to leave some space, and I'm going to push the 4 over. Then I'm going to do half of 3 and square it to get 9/4. Okay? And then I'm going to add that here, and I'm going to subtract it here. Okay? Now I can factor the inside. The inside's going to be x plus 3/2 quantity squared. I need to multiply the 4 by 4 over 4 so that I can add the two fractions together. So I'm going to get y is greater than x plus 3/2 quantity squared minus 16 over 4 minus 9 over 4, and those two are going to give me a negative 25 over 4. So now I know that my vertex is going to be a negative 3/2 and a negative 25 over 4. All right, so that gives me my vertex. I would like to find my x-intercepts, and I'm going to do that by factoring, because that's the fastest way. So I'm going to write y is greater than, and I can factor this using guess and test, so I'm going to have a positive 4 and a negative 1, because 4 times a negative 1 is a negative 4. 4 minus 1 is 3. So now I know that my x-intercepts are going to be a negative 4 and a positive 1. Alrighty. So now what I have is enough information to graph. Numbers aren't very pretty, but I'm going to go ahead and graph anyway. So a negative 3/2 is about a negative 1.5, and a negative 25 over 4 is a negative 6.25. So not very polite numbers, but they're okay. Alright, so then I'm going to plot my intercepts. I have one at 1, 2, 3, 4, a negative 4, and one at a positive 1. Put my two intercept dots. My vertex is at a negative 1.5, negative 1, 2, 3, 4, 5, 6, and a smidge. So there's my vertex, and that one has coordinates of the negative 1.5 and the negative 6.25. I know that my inequality says greater than, not equal to, so that means that my line is going to be dashed. So I'm going to draw my dashed line. And because I have a curve, greater than usually means above, and less than means below. So if I actually shaded my graph, if I can get a different color pen, my graph shading would be everything above that line, and that would be the solution to that particular inequality. All right. So now let me show it to you on your grapher, just because this is kind of cool. See if I can get it where there's not so much glare. All right. So first I'm going to go to my y equals. I'm going to clear everything that's there. See if I can get that with no glare. And I'm going to enter our original equation. And it was x squared plus 3x and then minus 4. And notice I'm in the y equals. And then what I'm going to do is I'm going to do a zoom 6. Because a zoom 6, oops, I need to turn my stat plots off. Second stat plot, I don't want to see that, so I'm going to turn it off. And I'm going to go back to my graph. Alright, so there's the parabola, and that's basically what we got. Now I want to do the shading, because I can actually shade on my calculator, and it's a fun toy. So I'm going to go to the left of my y equals, and I'm going to start hitting my enter button. Okay, that's a fat line. If I get a triangle that's up above, that means greater than, and I'll just show you the whole process. So if I have a triangle up above, that means greater than. The triangle down below means less than, and then that is like a bouncy ball that will trace your graph, which is kind of entertaining. That's a bouncy ball without a trace, and then I go down to dots, so I could have dots for my graph. So I'm going to go back, and I have to keep hitting enter. If you miss it, you have to go back and keep doing it, because you can't go backwards in that particular process. Now I'm at my graph. I've told it to be greater than, and I'm going to hit graph. It's kind of fun. Woo! There's my graph. So cool. Now it will not give you a dashed line for your parabola, so you have to know that that line is dashed, but it actually did the shading for you. So cool. All right. So let's move on and do another example. All right, I think I have enough room here, and then I'll also show it to you on your calculator again because it's kind of fun. All right, so this example is just going to say solve. And I'm going to have y is greater than or equal to x squared plus 2x minus 8. So the process is basically the same. I need to get my equation in vertex form because that helps me to graph. I'm also going to factor it to find my x-intercepts because I will need that information in a little while. So for right now, I'm going to start with my vertex form. All right, I'm going to use completing the square because it's my favorite. And I'm going to do y is greater than or equal to x squared plus 2x. Those guys are grouped. Scoot the 8 over. Half of 2 is 1. Squared is 1. That's a plus 1. There's a minus 1. I get greater than or equal to x plus 1 quantity squared minus 9. And I know that my vertex is negative 1, negative 9. Alright, so now what I'm going to do is find my x-intercepts, and I'm going to do that by factoring. So I'm going to factor my expression. I'm going to use guess and test. So the factors of 8 that subtract to give me 2 are going to be x plus 4. 4 has to be positive because the 2 in the middle is positive. X minus 2. So 4 times a negative 2 is a negative 8. 4 minus 2 is a positive 2. And I know that my x-intercepts are going to be 2 and a negative 4. So now I'm going to put all of that information on my graph. Alright, so here's my graph. I know that my vertex is at a negative 1, so there's my negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Get that down there. There's my negative 9, so there's my vertex. I had an intercept at 2, Okay, so there's that intercept. And then I had one at a -4, -1, 2, 3, 4. My inequality is greater than or equal to, so that means my line is solid. So I'm going to draw my line. Give me a couple of arrows, and then I'm going to shade. It says greater than or equal to, so I'm going to shade up above. All right, let me show you that on our grapher. So I'm going to clear our last one. I'm going to leave the greater than. Sometimes you have to reset that because it doesn't hold when you shift to a new operation. Boy, there's a wicked glare on my calculator. Okay, I think you can see it there. So then I'm going to enter the original equation. I have x squared plus 2x minus 8. I'm going to do a zoom 6. It's still bad. All right, there you go. There's your graph. There's your shading. Oh, so cool. All right, so now let's do an example of solving an inequality system. All right, so anytime you see the word system, that means there's more than one graph. So I'm going to solve a system of quadratics. All right, so my two equations are going to be y is less than or equal to a negative x squared plus 4, and I'm going to have y is greater than x squared minus 2x minus 3. So I'm going to manage each equation. So for my first equation, the vertex is going to be 0, 4. I know that the parabola is turned upside down because a is negative. And then I know that my x-intercepts are going to come from a negative x squared is equal to a negative 4. X squared is equal to 4. So x is going to be equal to plus or minus 2. So my x-intercepts for, I'm going to label these so I can talk about them a little bit easier. For the first one are going to be plus or minus 2. All right? Now I'm going to manage my second equation, and I have y is greater than x squared minus 2x. I'm going to do completing the square, scoot the 3 over. Half of 2 is 1 squared is plus 1. This has to be a minus 1. So I get y is greater than x minus 1, quantity squared, minus 4. My vertex is going to be 1, negative 4. And then I'm going to go back and factor to find my x-intercepts. So I have y is greater than, I'm going to do x minus 3 and x plus 1. A negative 3 and a positive 1 gives me this negative 3. And then a negative 3 plus 1 is my negative 2. So now I know that these x-intercepts are going to be 3 and a negative 1. So let me graph, and I'll do one equation at a time. Okay. All right, so if I graph equation number 1, its vertex is 0, 4. So 1, 2, 3, 4. There's my vertex. And my intercepts are at 2 and a negative 2. Less than or equal to, so the line is solid. And there's my graph. And then notice it says less than or equal to, so I'm going to shade down. Okay. Now I'm going to do the second equation. My vertex was 1, negative 4, so 1, 2, 3, 4. So there's my negative 4. There's my vertex. Oops, sorry, wrong side. There's my vertex. Okay. And then my x-intercepts this time are at 3 and a negative 1. This time it says greater than, not equal to, so my parabola is dashed. And this one says greater than, so I'm going to shade up. Okay. All right, and now I'm going to take a highlighter just so you can see kind of where the area overlaps. And that overlapped area is going to be everything kind of in there. All right. Okay, now let me show it to you on your grapher. All right, so wicked glare, maybe right there. Okay, if I go to my y equals, I'm going to clear. Since I already have greater than in there, I'm going to enter the second equation first. So I have an x squared minus 2x minus 3. My second equation is a negative x squared plus 4. and I need to give it its inequality. It says less than. There's the greater than, there's the less than, and move over so I don't screw it up. And now I'm going to graph. Okay, so there's our second parabola. There's the first parabola. That's so cool. There is your overlapping area. Gotta love having a grapher. Alrighty. We just have, I think, one more example, and then we are ready for you to start your homework problems. Alright, so let's do one more example. So this time I want you to solve, and your system of equations is going to be greater than or equal to x squared minus 4, very similar to our previous problem, and y is less than a negative 2x squared plus 8x plus 4. Okay, and this one I'm going to do by hand. Alright, so I'm going to number my equations so you know which one I'm talking about. So here's the first one. The vertex is going to be at 0, negative 4. I'm going to find my x-intercepts, and it's going to be x squared is equal to 4, so x is plus or minus 2 again. And I'm going to go ahead and put that information on my graph so I can do one at a time. Okay. My vertex was at 0, 1, 2, 3, 4, negative 4. There's my vertex. I have an intercept at 2, and I have an intercept at a negative 2. It said greater than or equal to, so my line is solid. Connect the dots. Greater than or equal to means I shade up. Alright, there's one. Now let's do our second one. Y is less than or equal to, I'm going to factor out a negative 2 so I can do completing the square. And I'm going to get x squared minus 4x and scoot that 4 over. Half of 4 is 2, squared is 4. But notice that this is a negative 8, so this has to be a plus 8. Okay? Alright, if I rewrite that equation, I have a negative 2. X minus 2 quantity squared plus 12. I know that my vertex is going to be 2, 12. And now I need to find the x-intercepts. Okay. I can do that from my original equation. So I'm going to actually factor out that negative 2 again, except I'm going to do it out of the whole thing. X squared minus 4x minus 2. Okay, not very helpful. So at this point I would have to do the quadratic formula on this piece to find my intercept. Sorry, I guess you can't see it. Now you can see it. So I'll do my quadratic formula to find my zeros, but I'm going to do that from negative 2x squared plus 8x plus 4. So my x is going to equal a negative b plus or minus b squared minus 4ac all over 2a. So if I simplify that math, I get a negative 8 plus or minus, and then I have 64 plus 32 over a negative 4. And now I'm going to get out my handy dandy calculator, and I'm going to do that math. Wow, that's bad. In my calculator, let me scoot this over a little bit. So if I do that math, I'm going to do a negative 8 in parentheses, so a negative 8 plus the square root of 64 plus 32, close for the numerator, divided by a negative 4 and hit enter, and I get that that's a negative 0.449. Do a second enter, bring it right back up, go in and edit that positive to be negative and hit enter, and I get a positive 4.449. So not necessarily polite numbers, but numbers that I can actually put on my graph. Alright, so if I graph that particular graph, that just was a lot of repetitive words, a negative 449 is about at a negative 1/2, so I'm going to put a dot there. And then a positive 4.49 is about a 4.5. 2, 3, 4, and a little bit. Okay. My vertex was at 212, so 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. All right, so there's my vertex at 212, way up there. I know less than or equal to, my line's going to be solid. There's my graph. And it says less than or equal to, so I'm going to shade down. Okay, so there's the shaded down. And then I'll use my highlighter to help you see the area. And it's going to be everything kind of in that weird little shape right there. So that's kind of cool. All right, let me show you on your grapher. Okay, see if I can get it again where the glare is not too bad. All right, go to my y equals. I'm going to clear what's already there. My first equation is greater than, so I'm going to do x squared minus 4. Then the next one is less than, lucky me, negative 2x squared plus 8x, and then plus 4, and then a zoom 6. There's my first one. And there's the second one. And that basically matches what we did by hand. All right, so that's the end of your notes. So let me give you the problems that you're going to do. Okay. All right, so here are your problems. Okay, I want you to graph the inequalities. So you need to make sure that you do your shading and do everything that we've been doing in all of our previous examples. All right, so your first problem is going to be y is greater than x squared plus 4x minus 12. You need to find the vertex, you need to find the x-intercepts, and then you need to shade. And you'll follow that same basic process for all of your graphs. Wow, it seems like the glare is just getting worse. How's that? Ah, a little better. All right, your second one is going to be y is less than a negative x squared plus 4x plus 2. Remember the same process, vertex, x-intercept, and shade. And then your third one is going to be a system. And it's going to be y is greater than or equal to x squared, y is less than a negative x squared plus 5, and then one more. So you just have 4. You're going to have y is greater than or equal to 2x squared, and then you're going to have y is less than a negative x squared plus 1. And again, this is a system. All right, those are your problems. It would be helpful if you do it on graph paper, but it's not required. So good luck, and I'll see you soon.